Hi everyone, in this video I'll be explaining you how to model this T-beam, that is flanged beam with the reinforcement, and here the material nonlinearity is considered and the load is dynamically applied at every one-third point. So total the span of the beam is 3 meters, and here the slab depth is 100 mm, and here the web depth we are considered is 250 mm, and again the width is 200 mm. So entire width is 450 mm. So the reinforcements are 16 mm diapars. So this is how it is provided. So yeah. So now I have started modeling. So this is the grid lines. To see how I have considered grid lines, I'll just show you. So I have considered x in the x direction every 0.2 meters. I have created the grid for 3 meters. So number of grids I require in x direction is 16. Similarly, in y direction I require 8 number of grid lines, and in z direction I require 6 number of grid lines. And these values, so x direction, as I explained you, it is at every 0.2 meters center to center, whereas y and z are calculated based on the edges of the beam section and reinforcement centers. For example, this 0.041 is calculated based on the cover to the beam. It is 25 mm plus 8 mm will be the stirrup and half of the main reinforcement. So that is 25 plus 8 plus 16 by 2. Again it is 8. So it comes to be 41 mm. Similarly, the other dimensions are calculated. Just give OK. And material nonlinearity we are considering in this model. So to define nonlinear materials, you need to go to define materials. I've already defined this concrete and rebar. I'll just as it is, I'll let you know how to define nonlinear material property. So for that you need to click on this show advanced properties, add new material. Here I have selected India concrete. Here I'll select user, click on OK. You'll get this window. In here go to modify or show material properties, and here go to nonlinear material data, and then here you should select user defined, and here you need to mention how many number of points that values you have. Those many numbers, maybe if you have some 10 or 15, just click 15, you'll get these values. You need to manually input stress and strain values, and then the graph will be populated here. So I'll just show you what I have already populated for concrete and rebar. Select concrete, go to modify or show material properties and nonlinear material data. So here, so these are the values I have populated for nonlinear concrete element. Similarly, for reinforcement also I have already defined. Go to rebar, modify or show. Again, modify or show nonlinear material data. We have this strain plots. Click on OK. So to start with the model, here I'll keep it in cross-section view. Yeah. So here I'll just draw the concrete as a dummy element now, as an area element wherever concrete portion is required. For that I'll go to this rectangular option and I'll keep it as property none only, and I'll just drag from here to here. Here the X-plane is at 0.4 meters. I want at 0. So for that, move down in list. Yeah. x equal to 0. Just same thing. It's a dummy area element. I have drawn this. Now I'll just mesh it wherever to make an element where we have this grid element, wherever grids are there, to have the final element. For that, go to once you select, go to edit areas, divide areas, and here I'll select visible grid lines and area edges. Yeah, visible straight grid lines with area. Just click OK. Yeah, it will get meshed. Now we need to extrude this area into solids. So here I have already created a solid as a concrete element. For that, go to define section properties, solid properties. Already one solid was there. That one I have selected material properties as concrete. So here, whatever property you want, you can change. Here if you want concrete, click on OK. Similarly, I have defined frame sections for the reinforcement. For that, go to here, section properties, frame sections. Here I have defined 16 mm dia bars. So circular element with 16 mm dia. So here property I have selected rebar, which we have defined. Yeah. Now to extrude this dummy element to solid concrete element, select, go to edit, extrude areas to solids. Here in the reverse direction I am extruding. So in the -3 direction I'll give it as 3 meters, and yeah, 1, click OK. Here you can see in the 3D view. So it is drawn. Now I need to draw the reinforcement. For that I'll take this first option, draw frame or cable. This print also I'll just make it as 3D, 16 mm dia bars only. So yeah, first slightly rotate it. This is the first corner, and similarly the bar will end at here. So I have drawn one bar. So to add other bars, what I'll do is I'll just select the same bar and then I'll just replicate it. Yeah, I selected that reinforcement. Go to edit, replicate. Here I just click on this pick 2 points on model, and this horizontally I just first point, and here I want the second bar. Yeah, click OK. Yeah, similarly again I'll replicate this. Go to edit, replicate. Again pick 2 points. From here to here I'll give, pick 2 points, that is from this point to this point, 0.068. OK. Yeah, it is done. Similarly again I'll select this one, go to edit, replicate. Again same thing, pick 2 points from here to this corner portion. and then I'll just, instead of OK, I'll just click on apply so that this window will return. So the same thing you can observe in 3D also, it is also getting updated. So again I'll select these two bars and then same thing, pick 2 points on model from here to here. Yeah. Click on apply. Again these 2 bars. Pick 2 points here to here. Okay. Yeah, now the model is done. For the confirmation, if you want to check, I'll just make it in extrude view here. Yeah, if you click on this display option, we can go to general options and extrude. Yeah, you can see here red color is concrete element and blue color is reinforcement. This is extrude view, this is normal view. Yeah, now I need to assign the support and I need to assign the loadings. So for that, what I'll do is, since it is a simply supported beam, I'll be assigning simply supports at both the corners. To assign the support, so only vertically I'll just restrain it as a simple support. So select these nodes. Yeah, I have selected on both edges. Go to assign, joint, restraints, just only simple support. You OK. Then coming to the loadings, so I'll be applying 2-point loads at a distance of 1 meter and 2 meter, and at the pressure point load. So before that, I'll just mesh it to make the elements still finer. For that, go to edit. I have selected entire thing. Go to edit, divide solids, everything 222. solid is divided. Similarly, I need to divide frames also, that is reinforcement. For that, we go to select properties, frame sections, 16 diapar, select. Okay, so 8 elements are selected. Go to edit lines, divide frames. So divide lines into number of frames. So that one what we can do is either we can give number of frames. So here we require 3 meter, 5, 10, 15. So 15 divisions we require. So 5, 5 each. So not 15, sorry, 30. Or else you can measure other options also is there. You can select this other one, break at intersection with selected joint site inventory. Let's see. I'll just select this one and give OK. I'll just select, so it didn't happen, so I'll just go to select properties, frame sections, go to edit lines, divide frames, the 30 and 1, give OK. That is divided, let's see. I think solid element has not properly divided. I'll just undo that. Now I'll just select it. Go to edit, divide solids. In each direction it is 2 parts. Click on OK. Yeah, now the thing is in X direction it is not only 2, it should be, yeah, at every 0.2 meters it has to be divided. So that's the reason it is not getting yeah, divided. Okay. Or else select it, go to edit, divide solids, this is just trial and error. We should check which axis is particularly 1, 2, 3, 4 and 5, 6. The face, which face is this is also not correct. And finally, the last option will work out definitely. Yeah, 2, 2, and this is 30. Click OK. Yeah, and that is done. Yeah, now the reinforcement will also work. Here we select properties, frame sections, select it, go to edit, edit lines, divide lines, and 30:1. It's fine. Okay. Yeah. You see, at the junctions it is split. I'll just save the model. So the next thing is I need to apply the load. For that, go to define load pattern. I'll define apart from the load, I'll define one more load as point load. And here it is. I'll just keep it as that. Okay. Sorry, add new load pattern and then click on OK. So to apply the loading as a non-linear, so I'll just define non-linear function with load increment of 0.1 seconds, load increment of 10 seconds, and with 0.1 intensity. So whatever point load I'll be applying, it will be as a non-linear, it will be applied. For that, add new function. So I just have function, add new function. Yeah, here. So I'll make it as convert to user defined. And then manually I'll update. So at 0 it will be 0, and at 1 it will be 0.1. Similarly at 2, time interval of 2, it will be 0.2. So anyway, in any uh, method we can update, instead of 1 2 3 4 we can give any other time interval. Here I have considered 1 2 3 4 4.3.3 and similarly 4.4. I'll be considering 10 time interval values. So click on OK. Okay. Next, we need to define load cases to apply this nonlinear loading. For that, go to define load cases. So this point load, it is under linear static, but when we need to change to nonlinear. Go to modify. Here select load case type as time string and nonlinear. Select this direct integration and all this, let it be. And here coming to load pattern, point load, same thing, ramp function. Here select nonlinear. Rest all remains same. Click on OK. Sorry. Now click on OK. Here you can consider collapse also. That is, if any point, if you know. So that particular point we need to mention so that it will consider collapse. So yeah, that's in next iteration you can proceed. As of now, I'll just stop up to here. Click on OK and I'll save the model and run the analysis. Run now. Since it is nonlinear analysis, it will take some time to perform the analysis. So in a similar way, you can create model for any material property that different grades of concrete with different stress strain values. You can create the model. Directly you can save the model with different names and just modify the material property and rerun the analysis. That will be sufficient. Yeah, now the analysis is done, so we can check the results. For that, it is similar to any other model. We're checking the results and all deflection, deform shape, and bending moment shear force. So since it is a solid model, we need to check in terms of stresses for bending moments and shear force. I'll go to point load. Since we have applied as linearly varying, so at time step 0 you will be having 0 deflection. At next step, time step 1, you can see some deflection. Just yeah, now you can see. Oh, sorry. The thing is, I have defined the loading, but I haven't applied any point load. That's the reason we are not getting any deflection. Uh, yeah, go to XY. Yeah, selected 2 points. You just go to assign joint loads, forces. Here I'll select point load and in Z direction I'll apply minus 500. So any intensity we can consider. So here for this analysis I will be considering 500. We can modify it later also. So minus because it is in downward direction. Yeah, it is done. And now I will run the analysis. Yeah, analysis is done. now we can check deform shape. So left side window is showing for dead load. Now we are in the right side window, and yeah, you can see already it is for 0.1 interval. Sorry, deform shape. Go to deform shape, point load. Just click on 1 second. So we can see the deflection. Again, I had already considered one at 1 second interval, but it is still while doing the analysis, it is still divided uh, time interval furthermore. So we are getting 0.1, 0.2, 0.3. So if you want to directly see at 1, 2, 3, 4 seconds, we can do that. Yeah, go to deform shape, and here directly you can enter 1 and give OK. So in while defining load case also, you can just define it by reducing that number of subdivisions time steps. For that is, if you go to define load cases, here again output time step size 0.1 is done. That one we could have reduced it further. Yeah, so this is for 1 second, and similarly for the corresponding stresses you can check. Solid S11 I'll consider point load. If we consider maximum and minimum, maximum if we see for entire section, it will calculate and that is for the point load. You can see the stresses developed in reinforcement as well, since it is bonded together. Since it is a solid model and fine mesh is done, it will take some time to load the results. the results will get populated. Due to some problem with the graphics card, the results are not getting populated. So you can check the results from your systems. Yeah, thanks for watching.